Good day, everyone. So, in today's lesson, we shall be looking at Newton's laws of motion. We are going to be looking at three laws of motion that were founded by Sir Isaac Newton. And these laws are going to be telling us how force govern the motion of an object. So, let's dive into this law. The first law is known as the law of inertia. And the law states that an object at rest stays at rest, and an object in motion continues at constant velocity in a straight line unless acted upon by an external force. That's the law of first law. So Sir Newton is stating in this law that an object will continue to remain in its position unless an external force acts on it, or an object will continue to move in the same speed or velocity unless an extra force acts on it before it can change that velocity. Very simple and very clear. Of course, when you keep any object anywhere, that object, maybe your barrel, that barrel remain in that position until maybe you pick it or you push it or you pull it. It will not change its position, it will not move. So that's what the law of inertia is stating, that an object will remain in its position of rest. When we say rest, that means not moving, or it will remain in its position of constant velocity unless an external force acts on it. So the total force acting on some object is zero. That's what this means. So the summation of all the forces acting on that object is zero. That is why the object is not moving. Neither is it changing its velocity. All right. So that is simple statement of the first law, which is known as the law of inertia. Then what then is inertia? Inertia is just the tendency of an object to remain at rest. It could be two types. We have the inertia of rest and inertia of motion. It's already stated in that first law. So the law of inertia or inertia itself is stating that the tendency for an object to remain at rest, or when it is inertia of motion, that the tendency of an object to keep moving at constant velocity. So this inertia can be inertia of rest or inertia of motion. Okay. Now, inertia versus weight. Inertia is more associated to mass because mass is constant everywhere. However, weight depends on gravitational field strength. So weight has no relationship with inertia because weight is not constant. But mass has a relationship with inertia because mass is constant anywhere, and it's stating the same thing as the first law, because the first law is also saying that an object will remain in the state of rest constantly except an external force acts on it. So let's see some of example of the first law. For example, now when you park a car, that car will remain in the parked position unless you drive it, which is the driving force now. So a car at rest is an example of inertia. Okay, inertia at rest. Bicycle braking. Now, when you are riding a bicycle and you suddenly apply a brake, okay, now that is also what inertia in action, because by the time that brake stop the bicycle from moving, then the bicycle will remain in its what in its inertia at rest position. Now, soccer ball rolling. When a footballer kick a football, now that football continue to move in a constant velocity in the air until another kick act on it. All right, that's another example of inertia or first law example. So then passenger launching forward. Now when a driver matches a brake, you see that everybody jacks forward. That's because an external force has been acted, and that external force is the brake. Before the brake was being matched, rather, every messenger remain in their what? In their rest position or in their constant velocity. But once that brake is marked, it changes the position of the passenger. That is another example of inertia in action. Now let's dive into the second law. The first law has opened our eyes to the fact that an object will not change its position or its at velocity unless an external force is acting on it. Now the second law is taking us deeper. It's stating that if this external force acts on the object, then definitely there will be a change. All right. So it's stating that the rate of change of the momentum of an object is proportional to the applied force. The first law said that that object will not move except you apply force. Now, the second law said that if you apply this force, the rate of change of momentum of that object will now be proportional to the net force. In other words, the more the force that is acted upon that object, the more the rate of change of momentum. What is momentum? Momentum simply means the product of mass and velocity. So this is what this law is stating by formula, that force is proportional to what? To the rate of change of momentum. The P there represents momentum, the T represents time. While the D there represents the change. It's a symbol of Greek called delta. So it means change in momentum over change in time. So second law has a formula F, which is the applied for, equals to rate of change of momentum. That means delta P over delta T. Okay, so the P, product of mass and velocity. Okay, so that's what the second law is basically saying, that the rate of change of momentum is proportional to the what? The applied force. Okay, now we can go further to break this down. Let's have a little breakdown here on this formula so we have a better understanding. Now, looking at this formula now, we can also say, okay, from here we have already said this one simply means force equals to change in the momentum. Okay, that is change, that is D. The momentum which is P is mv. Okay, mv over change in what? In uh time, which is T. Yeah? Let's just cancel the delta and let's assume that we are left with F equals to mv over T. Right? Now when you cross multiply that, you're going to have ft to be equal to mv, right? Now this ft is also another quantity in physics that we call impulse. So this ft, we use j to represent it, and that j represents what? Impulse. So in the second law, we have formulas that matters. The first one here, which is force equal to change in momentum over time, and where momentum is mass times velocity. And when you break it down, we have, because multiply it here, we have ft equals to mv. So the the ft there represent what? Impulse, and impulse simply means force times time. Okay, where the applied force itself is mass times acceleration. Okay, so if you substitute this one for ma, you will still have another equation. So this is the general formula that links force, acceleration, and momentum in the second law. So the second law combines three major quantities: force, acceleration, and momentum. All right. So let's proceed to the next one. Now that is about this second law. Now the third law of scientific Newton moment say that for every action there is equal and opposite reaction. Okay, for every action there is an equal and opposite reaction. Of course, we know that action and reaction are type of forces, but they are opposite forces. So the third law says that when there is an action on an object, then the object itself will have a reaction. Let us see an example on this. When a bullet is being propelled forward from a gun, when you shoot a gun and a bullet comes out of it, as the bullet is going forward, there will be a recoil. A recoil there means a backward force of the gun. Okay, if you are in the military and you have used a gun before, okay, you will see that when you shoot with a gun and the bullet comes out of the gun itself will pull backward. That's the reaction. I get it now. So the action there is the shooting of the gun, or the shooting of the bullet from the gun. Now, when you do that, the bullet goes out and go forward. Then the gun that that release the bullet, move backward. That's the reaction. Another good example of this third law is jet engine. When jet moves in the air, hot gases hot gases are being expelled, okay, from the rear, from the backward part of the jet, and then these hot gases will propel the jet from moving forward. So that's the reaction. When the hot gases is being, as we see it here now, when the hot gases is being released backward here, so what happens to the jet? It move forward. So this is the action. The hot gas is being the expulsion of the hot gas in the action, while the reaction is what is the forward movement of the jet. The same thing applies to rocket propulsion too, just like the jet engine work. So it applies to rocket propulsion. So this is how the third law works. For every action, there is an equal and opposite reaction. Okay. Now, coming to momentum again, there's a law that also governs momentum. It said, and it is called the law of conservation. Okay, law of conservation of linear momentum. Momentum simply means the product of mass and velocity. That means when an object with a mass moving a velocity, okay, at a particular point in time. Okay, now the law of conservation of momentum, what does it state? It states that in a closed system with no external forces, total momentum is conserved, or defined in a different way. The total momentum before collision is always equal to the total momentum after collision. That's what the law of momentum is saying, provided there is no external force. Okay, and what is that law stating? It's stating that, okay, imagine two objects, okay, moving in the same direction. Let us do a little experiment on that, a little explanation on that rather. So maybe you have an object, for example, maybe you have object A. Let's say the object is object square and it's object A, right? And you have object circle, object B. Okay, and they are moving in the same direction. This object A is moving in the right direction, object B is moving in the right direction, but object A is moving with a higher velocity. So definitely it will meet this object B. Let's say object A is moving with mass A and initial velocity A, and object B is moving with mass B with initial velocity B. Okay, this is momentum now, product of mass and velocity. Now, the law of conservation of momentum is stating that the total momentum of these two, in other words, MAUA plus MBUB is always equal to the total momentum of the two objects after they have collided. In this case, they've not collided, but eventually, because A is moving with higher speed and they now collide, let's say the result is now that the two of them now collide. So we have the square and the circle like this, they collide. So this is now B, this is now A. So the law is saying that the final momentum, the total final momentum is equal to the total initial momentum before they collide. So let's say that after they have collided, then the final velocity of A is now VA and that of B is now VB. So then the momentum will now be MAVA plus MBVB. So that is what the law of conservation of momentum is stating. But note that this law, this collision of objects are of two types. We have the elastic collision Okay, as you can see here, and we have the inelastic collision. What do we call elastic collision? Elastic collision is a collision that occur whereby there are two things that are being constant when it occurs. The kinetic uh, energy of the two objects that are collided remain constant, while they are not their momentum also remain constant or conserved. When we say conserved, that means they are constant. So for elastic collision, kinetic energy is conserved, one, and then momentum is also what? Conserved. Okay. Now for inelastic collision, kinetic energy is not conserved. Take note of that. And again, for inelastic collision, when the two objects collide, they stick together. So whenever two objects collide and they stick together and move with the same speed, then you know that it is what? It is perfectly inelastic collision that have taken place. But when two objects collide and they go their separate ways, then you know that it is elastic collision. So those are the major difference between elastic collision. So for elastic collision, we say kinetic energy is conserved, okay, and the two objects will bounce apart, okay, as you can see here. So when they collide, one will go its way, the other one will go its own way. This elastic collision. For inelastic, when they collide, you see that they will stick together. The two of them will stick together and go in the same direction. And then kinetic energy is not constant. So some kinetic energy will be lost. That's what we mean. And when it is now perfectly inelastic, they stick properly together and then go with common velocity, the same velocity after the collision. So take note of that. These are the things that occur during collision of objects, and then how momentum and kinetic energy is being conserved. Okay, so now that we have known the principle behind this law, the principle behind the laws of Newton, as well as the laws of conservation of momentum, let's solve one or two problems and then we call it a day. Now look at this question. It said a machine gun with a mass of 5 kilogram fires a 50-gram bullet at the speed of 100 meters per second. So let us write the parameters out so we don't get confused. Okay, now let's start all over again from the question. A machine gun with a mass of 5 kilogram. So let's say the mass of the machine gun is mg, g represents the gun. Then so mg is 5 kilogram, right? Now fires a 50-gram bullet. So that's the mass of the bullet. Let's call that one MB. Mass of bullet is 50 gram. But we have to convert it to SI unit by dividing by 1000. So that will be equal to 50 divided by 1000 to convert to kilogram. Okay. And when we do that, so here we have 5 here 1, 5 here is 20. So that will be giving us 0.05 kilogram, right? So converting 50 gram to kilogram would be 0.05 kilogram. Okay. Now going forward again, fire the bullet, 50-gram bullet at the speed of 100 meter per second. Okay. Now this speed is for wood. Is it for the gun or for the bullet? Of course, the gun is not moving. It's the bullet that is moving. So we know that the speed of the bullet is let's say that is u equals to 100 meter per second, right? Now the recoil speed of the machine gun. Now what will now be the machine gun speed? Remember that the gun will move backward. Okay, so we have it as the final speed of the gun. Okay, so let's say this one. What is the final speed of the gun? Okay, question mark. We do not know this. Now take note that the recoil speed of the machine is what we are looking for now. The machine gun. Now that's the final speed. But take note, before that, the gun was at rest. So the gun had an initial speed of UG to be equal to 0. Remember also that this is supposed to be the final the final speed of the bullet. So definitely the initial speed of the bullet, which is UV, is also at 0. So following the law of conservation of momentum, we know that total momentum before collision is equal to total momentum after collision. So we say that okay, that mg ug plus mb ub is equal to mg vg plus mb ub. Okay, now here we know that the mass for the gun is 5 times. Okay, 5 times, and then the initial velocity is 0, so all of this one becomes 0. Okay, then plus the mass of the bullet is also 0.05, so it's 0.05 times the velocity is also 0. So on our left it is 0. Okay, but on our right here now, take note that we still have the mass of the gun to be 5 kilograms, so that will be 5 times the final velocity. That's what we are looking for, that's times vg. Then now, because the bullet and the bullet movement and that of the gun movement will go in the opposite direction, so this what we have here will be minus, so the momentum will be opposite. Okay, it will be minus. Now our mb remain, the mass of the bullet is 5. Okay, the mass of the bullet is 50 gram or 0.05 kilogram. Okay, so we are leaving it as 0.05 kilogram because it will be in the SI unit, then times the final velocity. This should be v, capital V. The final velocity is 100. Okay, so everything on the right hand side, they are all 0. 5 times 0 is 0 here, plus this one amount to 0 2. That will be equal to, so we have 5 vg, then minus, so 0.05 times 100, that will give us 5. That will give us 5. Now if you take to the other side, that will be 5 equals to 5 vg. And if you make your vg sort of the formula there, your vg there, you make it your sort of the formula, your vg there will be equal to 5 over 5. That will be 1 meter per second. You understand? So the speed of the gun itself is 1 meter per second, and that's option C. Okay, 1 meter per second. Okay, I hope that is clear. All right, so we are going to be drawing the curtain here. I hope you're able to understand the application of Newton's law of motion and how the law is being stated. Thank you for listening, and bye for now.